Good evening, everyone. Well, I am going to be speaking today on Bayesian spatiotemporal forecasting of violent crimes in Trinidad, with contributions toward crime opportunity theory. So, just a bit of a background, we know that violent crime has always been a relevant issue in Trinidad and Latin America and the Caribbean region. And even more so with the recent events, we see a much more heightened response to the impact of violent crimes. Just to give a bit of statistics, Trinidad and Tobago's crime events are horrible. Well, in perspective with the other Caribbean countries, we are ranked just about here. This is data from 2015, but as we can see, we have been consistently over the years been ranked with one of the highest crime indices in Latin America and the Caribbean region. So what is violent crime though? So in a violent crime, the victim of a crime is harmed or threatened with violence, right? And so violent crimes could include things like rape and robberies, assaults and murder. And this is according to the definition supplied by the National Institute of Justice. We know that, as I said, violent crime is one of the most serious issues in Trinidad because it impacts not only on the social and economic development of the country, but also it resonates with a psychological, mental, and devastating impact on the well-being of the citizens of the country. And all parties are involved in trying to reduce crime, from government agencies to NGOs to the citizens themselves, right? But specific forms of violent crimes in Trinidad are more prone to appear when compared to other forms of violent crimes in other places. For example, because we are an avenue where there's a lot of high imports of drugs and guns and stuff, there's a lot of reports on woundings and shootings due to gun violence and homicides, of course. There's also a rise in sexual offenses, robberies, kidnappings, and assaults over the years from 2000 onward, right? Now, how do we look at violent crime? How do we analyze it? We can form patterns. We can see patterns arising in violent crimes. They tend to cluster in specific places known as hotspots, right? And certain areas in Trinidad may be perceived as well-known hotspots. But what causes these hotspots to form and what distinguishes an area as a hotspot? This can have several different definitions of what a hotspot could be, right? But the crime distribution may not be stationary or stagnant over time. It may be dynamic and it may continue to evolve. It could be a gradual evolution over the years. It could be spontaneous evolution over a short period of time. But the aim, therefore, would be, can we track these changes or can we use data to explain and predict where the violent crimes will occur so as to mitigate their impact, right? And the idea of using predictive policing or place-based predictive policing will become very important as a tool to do this. So before I actually go on to explain the objectives of this research or this presentation, I like to explain a little bit on some theories of crime and how they link to police. So one of the main theories of crime is social disorganization theory, which says that crime is not only carried out, the criminal individuals are not the sole responses, are not the sole factors that that could influence the criminal nature of the individual. It's really the neighborhood characteristics, right? So what do we mean by neighborhood characteristic? Is the neighborhood at a disadvantage in economical status, social status? Are they lacking anything? And some indicators of social disorganization could be residential instability, which is one that is used a lot in other research papers. The income inequality, heterogeneity of ethnic groups and religious groups, because informal social control is the ability to have some kind of social cohesion within a neighborhood. And if this is lacking, this could cause or this could encourage criminal offenders to commit the crimes based on their disadvantages. There's another idea of social disorganization that can be tied into social disorganization called collective efficacy. And this is the extent to which neighborhoods could attain social organization and control over public areas. So the ability of the community itself or the neighborhood itself to band together, right, to have one shared goal or one shared purpose is known as collective efficacy. So the community is watching over each other, being their brother's keeper, and therefore, if if they have strong social values within the neighborhood, then and the community reinforces those values, then the crime level will not be as high as one with low informal social control. But today I want to focus more on the theory of crime opportunity, which is defined as when offenders make rational choices and thus choose targets that offer a high reward with little effort and risk. So this means the offenders are going to be motivated to commit the crime. They have decisions that they are making such that they have some reason for committing this crime, right? Maybe it's because they're going to get a high reward in terms of getting monetary gain or going after something some victim that would erase evidence or something like that, right? But they have to do so with little effort and risk. So that has to be dependent on the rational choice of the criminal, right? Some criminals may not be rational, but most criminals, we could view them as making some kind of rational choice in their mind as to who are they going to target and how they are going to target them, right? And then it will all tie back into something called environmental design, in which the ecological factors or the structure of the neighborhood or the place in which the crime is going to be committed is going to affect how and if the crime could be committed, right? So, for example, in urban areas, you have higher tendency to have more crimes because there's a lot of people in the area. You could have places that are secluded, have limited lighting, things like that. All of those create opportunities for the crime to take place. And this brings me to one of the sub-theories in crime opportunity theory called routine activities theory, where there's an amalgamation or confluence of motivated offenders, vulnerable victims, and the absence of capable guardians. So the lack of collective efficacy where there's no social control over the victim or over the crime or over the criminal, right? And so, for example, routine activities theory could involve the seasonality patterns that could be exhibited by crime trends. For example, when students go to school or when people go to work, they are already in their buildings in secluded areas, away from the offenders. But during the nighttime, when they go to um, have some kind of luxury event or something, or go to parks or go to open areas where by themselves, they might be more susceptible. So day and night, seasonal patterns, events that could call to the victims to come out, like going to the beach on the summer. All of these things, right, could contribute to crime. So temperature as well, or weather patterns could even contribute to how crime trends vary, right? Because in the winter, most people are at home and safe, whereas in the summer they go out for leisure activities. There's also one point I want to talk about in terms of broken windows theory. So it's not necessarily under crime opportunity theory, but what broken windows theory is that it allows for the development of more serious crime based on the visible signs of lower level crime events. So for example, antisocial behavior, crime and disorder. So there was this famous example in New York, I believe, back in the 80s. I'm not sure if anybody looked at or read Tipping Point by Malcolm Gladwell. And he talked about the disorder that went on in the subways where people were writing graffiti. And this actually encouraged more serious crimes. So the police department ended up cleaning up the graffiti, making sure that they don't cut the lines and stuff, and that actually reduced the violent crimes based on that. So some low-level visible signs of crime may trigger more serious crimes in the future, right? And that's what broken windows theory is about. So back to Trinidad now. The data I used in this investigation consisted of serious crime reports from January 2012 to August 2015. And there was a total of 42,189 serious crime reports, where 16,688 of these crimes were violent crimes. Now, the data was provided by the Crime and Problem Analysis Branch of the TTPS, and each report would have contained the report dates, the police division, the police station, the location or the street address, and the latitude and longitude coordinates of the street address. However, a good few of the geolocations that were given were missing. So I used the geocoding API with Google to improve the geocoding success rate. For example, so I have here violent crimes, property crimes, and possession or trafficking crimes, which I group based on certain offenses. So like for violent crimes, we'll have the murders, the sexual offenses, the robberies, the assaults, the woundings, and shootings, right? But you can see that the success rate, the initial success rate is a bit low, is 89.8%, compared to the property crimes and the possession, right? Well, actually, it's not that low, but I wanted it to be a little over 90% at least, because I have to remove those geocodes, those non-geocoded data in my analysis. So I want to improve the amount that I will be using in my study, the amount of observations. Now, after geocoding, I have the final success rate, which is quite nice, high, well, quite high. Also, the property crimes and possession or trafficking. So the property crimes would be like breaking offenses, larceny, right? Things like damage to property or malicious damage. And possession or trafficking relates to either possession or trafficking of drugs or narcotics, or possession or trafficking of firearms or ammunition, right? And I included these two types of crimes for later analysis as it relates to violent crimes. So the data, right, could be geocoded, right, and viewed interactively as point or street level data, right, and you could do you could do spatiotemporal analyses on the point data itself, but I chose to use area level data based on police station districts, right? So we have 62 police station districts here, right? And you have, I will explain the reason why police station district and why monthly aggregation. So I chose to carry out my analysis on monthly data on a rolling window. So I started on January 2012, and I'm going to make one step ahead forecast for January to June 2015. So the training set would be from January 2012 to December 2014, and the one step ahead forecast would be January 2015. Then the rolling window will roll 1 month. So the next training set data will be from February 2012 to January 2015 to predict the one step ahead forecast for February 2015, and so on until June 2015. Now, the police station districts would have clearly defined boundaries for hotspot identification. But the pitfall is that there's something called the modifiable aerial unit problem, where if we go back to this chart here, this diagram here, you can see that the data tends to cluster along roadways, close to coastlines in the rural areas, but you can't really see that when it's aggregated at the district level, that information would be lost, right? And there could be irregular shapes in the hotspots, in the clusters that you wouldn't be able to capture with the district data. That is because no matter, you could change the shape of the district areas and you could get different results. So with this kind of shape with the district areas, you would have certain results that if you use another shapefile like a community set of boundaries or administrative level boundaries, you will get different results. But the other reason why I wanted to use police station districts was because I wanted to use the covariates that came along with the police station districts that could potentially explain crime outcomes. And then too, the geocoding may not be 100% precise. So because some of the addresses were street level and not exactly point referenced, so the data may not have been geocoded to the exact point of the location. So if you aggregate it, you will probably get a better accuracy and minimize this error, right? Now, there's also the fact to consider that the organizational structure of the TTPS is such that there's a hierarchy where you have police divisions, Northern, Eastern, Western, Southern, Tobago, right? And then within those police divisions, you have the police station districts. And maybe resources will be allocated to police officers based on district. And we could view the performance of districts and compare them directly. And this may give better insight on where to distribute these resources if we look at it from a police station district point of view. Now, why monthly aggregation? Well, monthly reports seem reasonable to carry out policy decisions. You could have meetings by the management and administrators of the TTPS to deploy resources monthly. Whereas with weekly and daily may require a lot more time and a lot more resources to have to discuss about. And then annual data may be too reactive rather than proactive because we still want to have some kind of proactive approach. But then too, the daily and weekly events might be too rare, right? Because violent crime is still a rare occurrence. Crime on the whole is a rare event. So when you aggregate it by month, it wouldn't be as rare as if you use daily or weekly counts. So the covariates that I have in the shapefile data are things like population, the number of households, the number of dwellings, which is something similar to the number of households, but is not exactly, because a household is something that is a physical building, but a dwelling could be more, it doesn't have to be a physical building, right? It's just where somebody lives. Then you have the number of buildings, the number of businesses, the number of institutions, and we have the number of males and number of females in the district. I use feature engineering to derive more variables, including the district area. So I calculated the area of the districts based on the boundaries. Then I also calculated something called population density, which is population over area, because I saw that that was a covariate that was used in previous studies. And I also looked at the sex ratio, which is the number of males over the number of females. Now, I also wanted to see if there was any triggering of violent crimes based on crimes that specific types of crimes that would have occurred in the district the month before. So, is property crime the going to drive violent crime in the future? And is possession or trafficking crimes going to have some impact on violent crime in the future, in the near future? Right. So I logged the data for property crime and possession or trafficking crimes by 1 month. So before I even began to model, I noticed that there was high correlations. There were high correlations between a lot of the explanatory variables. So there were a lot of multicollinearity issues. And one way to deal with multicollinearity is to use the variance inflation factor, or VIF. So in a regression model, right, the VIF is calculated as the value, as the ratio of the overall model variance to the variance of a model that includes only that single independent variable. And a high VIF would indicate that you have high multicollinearity between that variable and some other variables. So you can see a lot of the data is a lot of variables are highly correlated, like the population, the number of households, the number of males, number of buildings, number of dwellings, right? Extremely high VIF values compared to the smaller values for the other variables. So when you have high VIFs, you remove them and we run the regression, and then you will get lower VIFs. And then you continue doing that until you get a satisfactory VIF. The rule of thumb usually is to have a VIF less than 10, but this is just a rule of thumb. Some use less than 5, some use less than 7. So I only had to run rerun the regression once, and I got these VIF values when I removed these different explanatory variables here. So I was pretty much satisfied with this. So notice this was just a quick and dirty regression, not really the actual model that I'm going to run. I just wanted to see what kind of covariates might be useful predictors for the model I'm going to build. So I didn't, I just used the average property, the average drug firearm. So these are not time series. This is just an average over all the time. And I correlated with the average violent crime count for each district. So you can see here, initially, the correlation plot, you would have a lot of high correlations between variables here, weaker correlations between these variables, but when you remove them, the correlation still a bit high in some variables. But when we do the regression, we will see the estimates and what the result will be. So this is after the removal of certain explanatory variables that had high multicollinearity. So now going on to the Bayesian modeling part, where let me just give a brief explanation of what Bayesian modeling is. So let Y be the count of crimes in an area over a specific time period. Then we could say that Y is a Posterior distribution with mean count mu, right? Posterior is usually used for count data, but the key assumption of the Poisson is that the expectation of the Poisson distribution is equal to the variance of the Poisson distribution. That is, mu is equal to sigma squared, right? Now, the frequentist approach would use something called a generalized linear Poisson regression model with fixed parameters. So we have log of mu is equal to some parameter, some function alpha plus beta x, where alpha is fixed, beta is fixed, and x is some predictor variable, for example, the number of businesses. And what happens is that these fixed parameters will cause the response of the Poisson distribution outcome. So the Poisson is an underlying distribution that is generated by these fixed parameters or these underlying processes in the background, right? So y is a random variable that is generated by the fixed parameters. However, with the Bayesian approach, we have random parameters. So we still could have the same equation, log mu is equal to alpha plus beta x, where the predictor is the same thing. But now the y values, the observed values are fixed. So they are not, we are going to condition the distribution on these fixed values. So the Poisson distribution, right, is going to drive the value of the alpha and beta parameters. So therefore, the alpha and beta are now random and are dictated by the fixed values, which because they are conditioned on those fixed values. Now, hierarchical Bayesian modeling has different stages. So you have in this study, I employ a 3-stage hierarchical Bayesian modeling procedure, where the first stage is that you assume your distribution for the observed counts. So you have y given the parameter mu, right? Where and that is Poisson mu. You have the log-link function, right? This is just an example. Sorry, this is not the actual model yet, right? But stage 2 could be like having some other hyperprior being distributed. So you have alpha is the prior and sigma alpha is the hyperprior. So sigma alpha is going to drive the value for alpha as well, right? And then you have beta given theta is normal, theta 1,000. So these are just random, these are just examples. They are not, they're just to give a demonstration. And stage 3 now, you can define the distribution for the hyperpriors that will drive the alpha, which will then drive the mu, and the alpha and beta will then drive the mu, right? So the posterior distribution, which is pi of mu given y, right, is what we want to find. And that is going to depend on the likelihood function, which is y given mu times the prior distribution or our belief or how much information we could provide to say that this posterior distribution will be represented as such. So we could estimate the parameters by sampling from their full conditional distributions. So we could get the full conditional distributions for the parameters alpha, beta, sigma alpha, theta. And then remember the parameters are varying. They are not constant, they are not fixed, they are random. So we have to estimate the parameter from the distribution, which has to converge into some stationary posterior distribution. And then we could sample it and get the mean or the median, and you could get a confidence interval for our estimates for the parameters. And the traditional procedure to do this is through Monte Carlo, multi-chain Markov chain Monte Carlo simulation or MCMC. But in this case, I chose to use something called integrated nested Laplace approximation, which is INLA, which is a fairly recent development in terms of computing a Bayesian model. It uses a Laplace approximation, as the name says, to approximate the posterior distribution, and is more computationally efficient than the MCMC, because the MCMC could take hours, whereas the inner could take just several minutes, right? So now I'm going to look and see, is the Poisson distribution really a satisfactory assumption for my crime count data. So this is the distribution of the crime counts when aggregated by month and by police station district. So we can see that there's a high count of zeros, and the values for some crimes reach at around 60, although these are very low, right? So is my data over dispersed, meaning is my mean not equal to my variance? Because a key assumption for the Posterior distribution is that the mean must be equal to the variance. Maybe my data is zero inflated due to the high count of zeros. Maybe I could model my data to account for the overdispersion using a negative binomial distribution instead of the Posterior, where the mean and the variance could be different, right? So all of these questions I asked myself. And so this is an example of a normal Posterior distribution in the dark gray, right? So this point here, here, and then the over dispersed would have had a higher amount of zeros and a higher amount of, well, it will tail along to a higher amount of counts on this in this side, but with lower frequency, of course, right? So high frequency of zeros, very low frequency, but it extends way out. Whereas the Posterior doesn't extend that out because it doesn't have this high variability, right? So coming now to the actual model specification, let YIT be the count of crimes in police station district I, going from 1 to 62 during month T equal 1 to 37, because there are 37 months I'm going to model for, and then I'm going to predict the next month's data, the next month count, right? So YIT is Posterior and MUIT is the expected crime count. So I fit several models, and I'm going to just show 3 models here. The first one is a spatiotemporal model with no interaction. So there's no interaction between space and time, right? In this case, you have the intercept alpha. The beta is the set of covariates, which is a vector regressed onto the xi districts, where I is the district. UI is the pure unstructured spatial effect, and SI is the purely structured spatial effect. So in space, right, there is no independence of the data, like how you could assume for a normal regression. With space and time, there's autocorrelation, meaning closer values tend to be more correlated than values further away. So in neighborhood structures are important when looking at space-time models, right? Then we have unstructured temporal random effect, where there's independence in the time count, the time, but you could also have an a dependent variable dependence, which is psi t, purely structured pure structured temporal event, right? So that's, for example, autoregressive an autoregression on the previous time value, where so certain times at certain times you could have this next time going to be dependent on the previous value that it was the last month, right? And yes, this one is a model with spatiotemporal interaction. So it's the same model here, except that I've added a delta IT term, which would indicate, okay, this police station district has it has a mean, sorry, it has a violent crime count that is going to vary away from the global mean crime count at that time. So sometimes you could have an increase in time trend faster than the overall time trend, or a decrease in crime trend compared to the overall crime trend for each district, right? And now I also included one to model over dispersion by fitting extra variability on this epsilon IT value, right? which is one way to account for over dispersion by just adding an extra parameter to account for the extra variation that is not captured by any of these random effect terms, right? And to determine model performance, right, how well the model fits the data, the observed counts, I use the deviance information criterion, or DIC, which is equal to d bar plus rho d, and d bar is the model adequacy, and rho d is the number of effective parameters. So here are some results. I'm not sure if you can see them properly, but these are all the models I've fitted. I haven't shown you all the random walks or the autoregressive with autoregressive 1 or 2 models, but I use the AR1 temporal structure because it offered a better fit for the other models. So you can see here the DIC values for the spatiotemporal model, which is a type 2 interaction, right? I will explain what type 2 is soon, right? Gave the best DIC values, the lowest DIC values, indicating that this model was the best fit. So actually, this one did not give the lowest one. I'm not sure why you can't see why this one can't but if you look at it, right, the DIC for the green, the highlighted in green is lower because we have 9249.1, 9229.85 for when you fit it with January 2015. All of them are consistently lower. But DIC does not mean lower DIC does not mean better predictive performance, right? So when you calculated the MAE, or the mean absolute error, you would see that they are fairly similar, right? But the type 2 spatiotemporal interaction without over dispersion gave a better predictive response compared to the other one, right? Also, the time taken to run the model was significantly less. If you can see, we had the time for these is like 417 seconds all the way to 279 seconds. And these took 15, 29, 11, 40 seconds to run, right? So this one ended up being the most significant. So the type 1, type 2, type 3, and type 4 are different kinds of interactions you could have in space and time. So type 1 is just independent independent interaction where there's no structured temporal and no structured spatial effects interacting. Type 2 is when you have a structured spatial effect interacting with an independent or unstructured temporal effect. Type 3 is when you have a structured temporal effect interacting with an unstructured spatial effect. And type 4 is when you have both structured spatial effect and structured temporal effects interacting, and you have the Kronecker delta product of the priors being multiplied by each other to get the prior for the interaction term. So I hope that wasn't that confusing, but I don't have time much to explain too much about it as yet, right? Then we have the estimation of fixed effects from the best model. So I chose to use the type 2 spatiotemporal interaction model, and we can see the fixed effects here. We can't get p-values from the Bayesian models, but what we could do is get the Bayesian credible intervals, and we could see if they are significant based on whether they overlap with the 0 mark. So the 0 mark is shown by the dashed line here, right? And we can see that x1 overlaps, and x4, x5, and x6 overlaps. So these indicate that these are not significant predictors for the model, right? So population density is not significant. The number of institutions was not significant. The property crime count in the previous month was not significant, and the possession or trafficking of crime count in previous months in the previous month was not significant. The only significant predictors found that affected the crime count was the number of businesses in the police station district and the male to female ratio. Note that there was a positive impact on the number of businesses because this was greater than 0, and there's a negative impact on the male to female ratio. So this means that the more businesses that are present in the district, the higher the violent crime count will be. Whereas when there's a higher male to female ratio, there's a lower impact on the crime. I'm sorry, there's a lower amount of violent crimes. So high male to female ratio indicates that there are less females in the area. Less females may mean that there are less targets, which may decrease the opportunity for the violent crime to occur because the victim hasn't appeared in the confluence of the motivated offender and the victim and the lack of the capable guardian according to the routine activities theory. Whereas high number of businesses would theoretically cause a higher crime count because you have a more urban area. There's a lot of people that will be in the area, a lot of potential victims, right? A lot of opportunities for robberies and stuff like that as well. So those were two interesting results, I think, that came out of this study. We also have the estimation of the random effects. So how the random effects could contribute to the variation of the crime count. We could measure something called the variance partition coefficient, or VPC, right? Where we could see the majority of the variation is due to the higher VPC values. So most of it shows that there's a high temporal dependence of the crime counts, meaning that the crimes are heavily affected by the previous month's values of that violent crimes, right? So we have we see it clearly for the row for the month, which is the pure temporal structured effect, as well as the interaction in the district itself, the temporal interaction for the district, right? 0.514. There are some significant variation that is induced from the spatial component, sorry, not the spatial, the IID component, 0.07. But not so much from the spatial component. This is suggesting that crime is more heterogeneously distributed rather than structured in space. So it doesn't really cluster that much, it's more heterogeneous in the structure, right? So this is some results for the forecast of the total crime counts using the models. I realize I have not labeled these trends, but the most of them are similar. So the red here on top is supposed to be the naive model, which is just the previous crime counts, right? So if the police hasn't used any data analytics at all, they may assume that the crime in the district might just be the same as the month before, right? Of course, this is not an ideal model at all, right? But I found lower error when the lowest error when you did the spatiotemporal model with the type 2 interaction indicated by the blue line, although it's still not as satisfactory, right? I suspect that there's a lot of strong temporal dependence that is causing it to be like this. So I still have to rework the models and see if I could improve the forecast accuracy. But the DIC values indicate strong fit towards this. So you have confidence intervals along these training set, and this model fits the best as well. So this is just showing you the forecast for the total area of Trinidad, right? But if we want to look at individual districts, right, we can see that you have the months from January to June 2015, and this is the predicted violent crime counts. So if we go back, you can see some errors that might be high. So if we compare the errors now, we want the errors to be very low throughout all the districts, but we can see that in this community, in this police station district, which is Valencia, it's consistently overestimating the crime counts most of the times for some reason, right? But other than that, most of the results in the districts are fairly okay, right? Some of them are still high, like these are underestimating, right? In this district here. So in conclusion, we have that violent crimes in Trinidad police station districts are influenced by environmental and social characteristics, which gives some support to crime opportunity theory. And we saw that this includes the number of businesses and the male to female ratio. Violent crimes in Trinidad police station districts do not seem to be driven by the number of property crimes in the previous month, nor the number of drug or firearm possession or trafficking offenses in the previous month. Maybe this means that there is no impact at all, or maybe there's a more long-term impact and I have to go and investigate for more than just 1 month. Maybe I have to look at more aggregated over a longer period of time to see the impacts of it. And then there's evidence of spatial and temporal trends or accounting for violent crime count variation and the Bayesian spatiotemporal modeling with the type 2 interaction and without the over-dispersion parameter provided the best forecast results when compared to other competing models. So here are some of my acknowledgements. Kappa, of course, for providing the data, and Dr. Sipasad, Dr. Ramlal, and Dr. Diyal Singh for certain guidance. And that's it. I apologize for the length of the duration of this presentation in advance, but I welcome any questions and comments. Thanks a lot for listening.
Yeah, and now I have a couple of questions. So basically, you look in terms of temporal, you look month to month, but you didn't look year to year, right?
No, I didn't look year to year. No.
Well, I know you have limited data, but to me, what happens in February this year should I would correlate. I would think would correlate better with what happened with February last year as opposed to what happened in January this year. Because crime tends to
because of the seasonal component to crime.
Right.
Yes.
So
yes.
February's carnival, you tend to have potentially more activity then. So if you could go back to I think 17. Yeah. So so here in fact I was just kind of glancing at this, and if you look at the error for February, it tends to be, well, I guess it's not consistently higher, but it tends to be a little bit higher than the other months.
It is consistently higher than the other months. For all of the models, we see it is consistently higher.
And potentially that could be because that's around carnival time.
Yes, that is a possible reason for sure. Yeah.
And so at least in my mind, taking the month in the previous year as a feature instead of the previous month might potentially improve things. But so that's one thing. The other thing is in terms of additional data, because you have this data that you got from the police, but do you have any other data sets you could use to confirm or validate this data in any way? Because if it's
you're talking about the covariate data, like the police station, the population data and stuff like that.
Well, the crime data,
no, all of the crime data I have comes from the police station, from Kappa.
Okay.
Yeah, I don't know if there's any other sources for the data, other than from Kappa. I don't know if that's possible.
Okay. Okay.
Yeah.
No, yeah, that's fine. I know it's difficult getting data. One other thing I was thinking might be interesting to look at is, you know, if you look at satellite imagery, for instance.
Yeah, so I am going to do that in the future because I want to know the distance between the crime and major roadways could be a good predictor. The amount of forested areas could be like the coverage of the area might be an indicator as well. So I was thinking of using satellite imagery as well, just that I haven't gotten to do it yet.
Okay, okay, especially at nighttime, because I would say, you know, again, this is just a wild guess that if you look at a nighttime satellite image and you look at the sort of brightness of different areas, that should kind of be correlates somewhat with well, it will correlate with activity, and you know, activity will correlate with crime, I guess. But yeah, that's potential.
Yeah, so yeah, crimes cluster a lot in urban areas, as you could see from this. Yeah, and most of them yeah, the violent crimes like the murders and homicides and stuff, they mostly cluster, as you would expect, in the Port of Spain area. But more robberies are more distributed along the central parts as well, and the northern and southern. So that was interesting as well. Although I aggregated all of the violent crimes because I wanted to look at it as a whole set rather than just an individual form of violent crimes for now.
Okay, one other thing you could potentially do is, you know, of course, you could optimize the police districts as well, right? I mean, I guess that it's impossible to implement it, but theoretically, you could form better districts based on the crime frequency, etc. Right?
Yeah, you could do that.
Yeah.
As well, but I don't know if they will implement.
No, they won't. They won't. But of course, you know. But maybe the other way to look at it is resourcing, right? You could, even if you keep the districts as is, you could reallocate resources according to the crime rate, etc.
Yeah, and that is one of the intents for this as well, because based on the if I could accurately forecast the demand of the crimes, I could develop an optimization strategy for the resource allocation to each district, which is why I chose to look at the districts as well.
Okay. Yeah. All right. Thanks. Nice work.
Hi, Navin. Nice presentation. Actually, on that point, interesting enough, I just saw a paper that was related to this something a similar issue, but a bit more abstract in terms of like things like districting. You can there's a paper I can send it to you, but it's a paper called Ordinal Approximation for Social Choice Matching and Facility Location Problems Given Candid Positions. So it's actually a recent paper.
Location. Okay, facility location maximization problem.
Yeah, it's a problem. Yeah. So just probably shoot me a reminder. I could probably give you a link to the paper.
Yeah, I'll do that. Thanks a lot, MZ. Yeah.
Also, there's this mathematician. She was recently on Steven Strogatz's podcast. Let me see if I could just find her name. She does work in Moon Duchin. She does work in electoral district creation to balance out certain metric. She's just an optimization problem. So I think some of her work you can probably look into repurposing it for yours.
Okay. How you spell the name? Sorry,
Moon as in Moon Duchin. I think that's how you pronounce her last name. Duchin.
Okay. Thanks.
No problem.
Hey Navin, good night. Really good presentation. I had a question on whether there was any additional census data available to tie to particular police districts.
Yes, so that was my initial aim to do as well. But the problem is I have the census data, but the census data is 2011 data, and I think this population this shapefile data given is a little more recent. I think it was in 2018. However, that's not the only problem. The problem with the census is that it's difficult to merge with the data that we have for the police station district or vice versa, right? So in the census, I have 534 communities, which I was going to get things like unemployment rate, education, the percentage of unmet basic needs as an indicator of poverty level. There's a lot of rich data on health and stuff as well, provided by the CSO. It's painstaking, but I am still working on merging the data itself because I have to do it manually because there's some missing information that causes some problems with the merging.
Okay, cool, no problem. Something I noticed about when you were talking about the final factors, and one of them stood out to me was the male-female ratio.
Yes, I was surprised as well.
Yeah,
because let me go back to it.
But I was wondering, Navin, if perhaps there's a little bit of a skew there for certain areas. Like the first areas that come to mind for me are like Port of Spain and San Fernando, where those are like high transit points. Like lots of people pass through those areas at various hours of the day, and the male to female ratio probably doesn't capture really the amount of vulnerable people, whether they be male or female, because perhaps the perpetrators of certain crimes are not necessarily from that area.
Yeah. So a lot of previous studies actually use things like residential population and things like that to as a covariate. But you can see here that my population was highly collinear, right? And population density didn't correlate, didn't give significant results. So I surmise that is because of the high travel rates of the people, because people in Trinidad don't stay in one place throughout the day, as compared to cities where you have, if you're looking at Chicago, for instance, you have fixed populations that they are investigating in the area. But Trinidad is a small island and everybody goes everywhere from district to district all the time, right? So maybe that could be a factor influencing the male to female ratios explanatory effect. I have to look more into that, but that's an interesting point.
Cool.
Actually, along that point, I have a suggestion for a possible covariate, but it might be a very stupid suggestion, so please don't judge me for it. A heat index.
Heat index in terms of temperature?
There's some research that suggests that hot temperatures are associated with higher crime rates.
Yeah, I mentioned that in my presentation.
Oh, you did? Oh, sorry.
Yeah, but yeah, I know of it. But the problem is to get spatial data. I tried looking to see, but I haven't found any. I don't know if you might have any insight into where I could find it, if possible. But I suspect that would have an impact. Would be a good covariate to look at. If I could get the spatial data associated with either weather patterns in Trinidad, because it's difficult to get the spatial distribution of the weather patterns unless you have some source that I could look at.
Didn't Data TT have some information? I think you had some weather information there, right?
Yeah, we used to have some weather. I'm not sure how. Yeah, if it's still there. It used to be on maps.tt, but I think we decommissioned maps.tt. So, but you could. I see you're in contact with Dr. Ramlal, right? Navin,
yes.
He might have data along. Yeah.
Yes, I will further contact him about that specific point then. Thanks.
Another question from me, if you don't mind.
Sure, no problem.
I think expanding on Inzamam's point, what about like to test if the heat index is a valid covariate? What about gathering average heat indexes from throughout the year for the different districts, and creating dummy variables? So you have like the average heat index for one district, or let's say east, west, north, south, and just like seeing if those make any difference. I don't know how sensible that is, but try and get averages, try to narrow it down per region of the country,
Right.
and see and create dummy variables and interaction variables with them to see if it makes a difference in the basic linear regression first.
Mm-hmm. Yeah. Yeah. Sure.
So I have a question. I should probably show myself. Hi, everyone. So the just some comments and I guess a few questions. With respect to the, so the first thing I noticed is that the crime types are sort of like all merged together. So I'd imagine that the majority of your violent crimes are predominantly robberies. Yes?
Correct. Yes, that is correct.
Yeah. So then that would explain, like, so I would actually suggest perhaps if you were to disaggregate maybe robberies from, say, maybe break-ins and maybe sexual offenses are pretty small, but homicides, for instance, and you could probably alter the type of model that you use. So maybe a zero inflated for the lesser, the crimes that occur less frequently, for instance, and stick with the Poisson or negative binary. I don't know which one you used, but I think you might get a better fit if you were to disaggregate the crime types. That's the first thing. The second thing is that possession. When you talk about like possession in crime, all the possession categories depend on police activity. So if the police, for instance, have some sort of an operation, you're going to find that they find more guns, they find more activities, as opposed to crimes that are reported by members of the public. So that there's that sort of that's sort of might also explain the lack of a relationship.
Yeah, because that's more reactive than proactive, because the police have to find the possession crimes rather than the. But so let me address your first point with the disaggregation of the robberies. Yeah, so I actually did a previous study on robberies alone with the Poisson. It fit well. It didn't require the zero inflated or the negative binomial at times. So yes, I could see how the disaggregation could have different distribution fits. I did actually fit zero inflated and negative binomial to the data here, although the DIC values were not lower than the Poisson distribution. So I did not include those in the presentation. But yeah, so I agree. Sorry, go ahead.
Yeah, I was going to add just two more points. The first is that I'm not sure if you're aware, but like I looked at I guess I don't know if it's if that would have been a predictive posterior that you did, but I guess it's the one of your predictions, and you had that serious drop in was it July in the middle of 2013?
Yes, I wondered about that drop, and I don't know why that drop happened.
Yeah, so one of the interesting things that would have occurred in 2013 at around that time was that the police service would have been running a hotspot experiment in collaboration. I think it was with Cambridge University, Professor Sherman, yeah. So he operates the Center for Evidence-Based Policing. So you can look it up. Stephen Williams, the former commissioner. So they did this study where they split the all the station districts into basically two, treatment and a control, and they executed, or they would have implemented hotspot policing, which is they looked at the location of crime based on Kappa, based on their analysis, whatever it is, looked at a street level hotspots. So, and then they applied just what the standard hotspot policing activity requires, essentially. And that, I think, ran in 2013 for a couple of months, if I'm not mistaken. They were targeting mainly shootings, woundings, and homicides. So they claim to have seen some sort of an effect, and then it led to whatever they did afterwards. But that was pretty much what I thought when I saw that drop there. That was interesting. That's the first thing. The other thing is that you said that there was a problem with the police station shapefiles not working out with not meshing with
the CSO data. Well, it's not really the fault of the police station district. It's more of the fault of the CSO data, because well, I don't know if the CSO gave me a bad shapefile, but I had to make modifications to remove the artifacts from it before because there were duplicate communities
There
in
were
there.
overlaps, things were overlapping. And
Yeah. And also with the communities, I think they would have updated the names of the communities or merged certain communities together as well. So you have like two communities merging into one, and they have data for two communities, but they only have one in the shapefile, things like that. But the police station district data, I also got a bad shapefile from them because Rio Claro police station was missing. So I had to fill that in, and I estimated the covariates for those, which is like that's not good practice, but that's what I had to work with at the time.
I did something similar, and I encountered the same problems, and basically I redrew it from scratch using the ED from the CSO, which is the best map that exists essentially, which is the smallest possible division, and then everything is based on
what they call it
enumeration district.
enumeration district. You have that shapefile. Oh, that's amazing. You can't send that to me.
We could talk.
Okay,
I send it.
I would love to talk to you.
But everything is built on that. Like everything is built on that essentially. So that could use that. So yeah, and the police station shapefiles, for instance, were corrupted. It is corrupted. I don't know what they do or how they do things. But finally, my final point is with respect to the covariates that you looked at, I think you might find more success with if you look at like maybe measures of like of poverty, for instance. Maybe look at the number of AC units, number of pools in the, you could compute that from the underlying census information.
Yeah.
So look at like air conditioned units, look at like pools. Ethnicity is also interesting because there is like this sort of it is interesting. So put, for instance, like maybe like East Indian over African, for instance, and you could look at the others in a similar sense. But that may also prove to be very useful.
So I have intentions of doing it because I have looked at the CSO data for it and tried to get the data. I have the data for it at the community level, right? It's just to incorporate it into the analysis at the community level. But I still in the process of cleaning up the data properly. But that's interesting. Thanks for suggesting it. The problem I think might be the issue might be with missing data in communities or electoral districts on non-responses to questions about AC units and housing. Because when I looked at it, there's a lot of missing data for those things when compared to other things like the level of education, working, even unmet basic needs, which I think might be a good indicator of poverty. So yeah, I want to incorporate all of those things in the study. Just I will have to estimate the missing data as well, right? Which is not really an issue too much. But yeah, really interested and excited to do that as well. So thanks for bringing that up.
Hey, Navin, just a quick suggestion too. You could use satellite photos from Google Earth and then use some computer vision algorithms to get things like housing area, like average housing area in districts, or things like proximity to neighbors, so like denser communities as a covariate as well.
Yes.
Yeah, I think those could be cool because it could kind of like fill in a lot of those missing gaps too if you have missing data.
Yeah, definitely. Yeah. Because I do want to analyze the data at the point level as well. I want to look at something called spatiotemporal point process, where there's a background rate of crime determined by an intensity function, and you have a trigger function that could generate offsprings to the crime. So there's this underlying process that could generate the offsprings that could trigger the generation of crimes around that observed crime. So that I kind of really interested in looking at that at the point level data, because if I'm going to examine the rarer crime counts like the murders and the kidnapping is even lower than murders. Think that might be the best way to do it in terms of analyzing it at the point level rather than aggregating it. Because of course, if you have lower crime counts, you will have a poorer fit in the distribution, even if you account for over dispersion.
Yeah, that sounds very cool. Very interesting stuff, Navin.
Yeah, thanks.